Hello everyone, welcome to this lecture series on thermodynamics. Today in this series, let's discuss temperature entropy diagram, that is TS diagram. We know that the working of a Carnot's engine can be well understood with the help of a cycle which is known as Carnot cycle. So this Carnot cycle is generally plotted on a PV diagram, that is pressure volume diagram, by taking the volume on x-axis and pressure on the y-axis. Similarly, the Carnot cycle can also be plotted on the temperature entropy diagram, that is TS diagram, by taking entropy on x-axis and temperature on y-axis. So we know that in the Carnot cycle, we can estimate the work done by the Carnot's engine, and from that we can calculate the efficiency of the Carnot's engine. Similarly, with the help of TS diagram also, we can calculate the work done and estimate the efficiency of the Carnot's engine. Now let's see what exactly is TS diagram. So TS diagram is nothing but the graphical representation of changes in entropy and temperature. Generally, entropy is taken on x-axis and temperature is taken on y-axis. The shape of TS diagram is a rectangle and is also known as a tephigram. In an isothermal process, as the temperature remains constant, the isothermal process can be represented by a straight line on the parallel to the x-axis, that is where we have taken the entropy on the TS diagram. Similarly, in an adiabatic process, the entropy of the system remains constant. Hence, the TS curve for an adiabatic process is a straight line parallel to the y-axis. So this is the general representation of a TS diagram. Now let's see the Carnot cycle on the TS diagram. Now let us consider a Carnot cycle where the working substance undergoes the following 4 cycles of operation. The first cycle is isothermal expansion where the temperature remains constant. Second one is adiabatic expansion where the temperature falls from T1 to T2, and third one is isothermal compression where the temperature remains constant at T2, and fourth one is adiabatic compression where the temperature rises from T2 to T1. All these 4 operations are represented on the PV diagram as well as the TS diagram. So on the PV diagram, we can note down the changes in pressure and volume, while the simultaneous changes or the corresponding changes in temperature and entropy can be noted on the TS diagram. Now let's calculate the work done by the Carnot's engine from the TS diagram, and ultimately let's estimate the efficiency of the Carnot's engine from TS diagram. For this, let us consider the TS diagram where we have plotted the entropy on x-axis and the temperature on the y-axis. So during the isothermal expansion, that is the first cycle of operation AB, which is taking place at a constant temperature T1, the entropy of the working substance increases from S1 to S2. Next, during the adiabatic expansion BC, there is no change in entropy. That is, the entropy remains constant during an adiabatic process, whether it is an expansion process or compression process. But the temperature falls from T1 to T2. During the isothermal compression, once again, the process is taking place at constant temperature. So the entropy decreases from S2 to S1, while the temperature remains constant at T2. During the adiabatic compression dA, the entropy once again remains constant, while the temperature rises from T2 to T1. So these are the 4 cycles of operations which are taking place while the working substance is undergoing the 4 types of operation as we have represented in the PV diagram. Now let's calculate the work done with the help of this TS diagram. Now let Q1 be the quantity of heat absorbed by the working substance in the isothermal expansion process, that is during AB. Then what happens when it is absorbing a quantity of heat Q1, the entropy of the working substance increases, and it can be written as S2 minus S1 is equal to Q1 by T1. change in entropy is the ratio of quantity of heat absorbed to the temperature. That is, from this equation, we can estimate what is the quantity of heat absorbed by the working substance. Q1 is equal to T1 into S2 minus S1. According to first law of thermodynamics, what is Q1? Q1 is the amount of heat absorbed and which is equivalent to the work done during that process. Similarly, here between B and C, we cannot, since it is an adiabatic process, entropy remains constant in this process, so there is no change in entropy. Now let's calculate the change in entropy between C and D, which is an isothermal compression process. Here it is rejecting a quantity of heat Q2. So Q2 be the amount of heat rejected by the working substance during the isothermal compression CD, which is at a temperature at T2. Then the change in entropy of the working substance is S2 minus S1 is equal to Q2 by T2. That is, Q2 is equal to T2 into S2 minus S1. So we know the quantity of heat absorbed and quantity of heat rejected during the isothermal process AB, that is expansion process, and during the isothermal compression process CD. Here between D and A, what is happening? Adiabatic compression is taking place. That is, once again the entropy is remaining constant. So we have to calculate the change in entropy along or during AB and during CD. Now we can calculate the efficiency of the Carnot's engine. We know that efficiency is defined as the ratio of work done to the quantity of heat absorbed, that is W by Q1. The W is nothing but Q1 minus Q2, quantity of heat absorbed minus the quantity of heat rejected, to the ratio, that is Q1. So what is Q1? T1 into S2 minus S1 minus T2 into S2 minus S1 by T1 into S2 minus S1. On simplifying this, we will get eta is equal to 1 minus T2 by T1, which is similar to the expression which we have obtained in the work done by the Carnot's engine, that is Carnot's cycle. Eta is equal to 1 minus T2 by T1. So that is the efficiency of the heat engine. Now let's see the uses of TS diagram. This TS diagram provides several advantages in understanding various thermodynamic cycles. The TS diagrams are used to know the thermodynamic state of the substance. They are used to study the defects in heat engine. They are also used to determine the efficiency of the heat engine. They are used to calculate the calorific value of fuel. They are also used in the Department of Meteorology for studying the atmospheric changes. So these are some of the uses of TS diagram. So ultimately, the TS diagram is the type of diagram which is most frequently used to analyze the energy transfer system cycles. It is also used in thermodynamics to visualize the changes in temperature and specify specific entropy during a thermodynamic process or cycle. So hope you have understood the TS diagram and how we can calculate the work done by the working substance during the Carnot cycle or Carnot cycle of operation, and also estimate the efficiency of heat engine with the help of TS diagram.